Hello students, I am Mr. Adinath Badar, Assistant Professor, Department of Chemistry, late Pushpa Devi Patil, Arts and Science College, Risod. Today, in this video lecture, I am going to discuss topic for B.Sc third year student, Unit 1st, Part B, lecture number 5, and then topic is chelates. So, firstly, we see the contents of this video lecture. So, firstly, we see the introduction to the chelates, then examples of chelating agent, types of chelating agent, property or ideal chelating agent, application of chelating agent in various industries, drawbacks of chelating agent, conclusion and reference. So firstly we see what is meant by chelate. A chelating agent is a substance whose molecule can form several bonds to a single metal ion. In other words, chelating agent is a chemical compound that react with metal ion to form stable soluble complex. For example, ethylene diamine, oxalato ion, EDTA, etc. The process in which chelating agent coordinated with metal ion is called chelation and the resulting complex is known as chelates. For example, here are some examples. These are the oxalato anion. One anion form two bond. These are the EDTA, ethylene diamine tetraacetic acid. Here, one EDTA molecule forms six bond with a single metal ion. These are the ethylene diamine. Now, the next protein, polysaccharide, and polynucleic acid are the excellent polydentate ligand form with or form many metal ion. Amino acids such as glutamic acid, histidine are typical chelators or typical chelating agent. Another example that is naturally occurring porphyrin ring is in a hemoglobin and chlorophyll acts as a chelating agent in natural, that is hemoglobin and chlorophyll. The porphyrin ring acts as a chelate to coordinate the metal ion. These are the porphyrin ring. These are the histidine naturally occurring amino acid. These are glutamic acid. These are also amino acid. Here, one porphyrin ring form four bond with a single metal. Here, this histidine also form one, two, three, four bond. Here, glutamic acid also form one, two, three, four, five bond. These are the example or naturally occurring chelating agent example. Example of metal chelate. Here these are ethylene diamine. These are the ethylene diamine form one ethylene diamine form two bond with cadmium, that is the metal. These are the chelate of EDTA. I told the one EDTA form six bond with the metal ion. One EDTA form six bond or six coordinate bond to the one metal. For example, this whole molecule are EDTA form six bond one, two, three, four, 5 and 6. Here ethylene tetraethylene triamine. Here one tetraethylene triamine form four bond with copper. This is called chelate and this process is called as chelation. Another topic is types of chelating agent. Classification of chelating agent made on the basis of number of atoms in molecule which coordinated with the metal ion. They are classified as, if they form two bonds with metal, then it is called as bidentate ligand. For example, ethylene diamine oxalato ion. Another type is tridentate. If one ligand forms three bonds with the metal ion, then it is called as tridentate ligand. Diethylene triamine 2,2,2 terpyridine also form three bond with a single metal. Then tetradentate ligand, we see the last triethylene tetraamine example, it forms four bond with a metal. Another example, another type is pentadentate ligand. If one ligand form five bond with or five coordinate bond with metal, then it is pentadentate ligand. For example, ethylene diamine tetraacetate anion. Ethylene diamine tetraacetate anion. Another example is hexadentate. Here, hexadentate. If one ligand form six bond with a single metal, then it is called as hexadentate ligand. For example, ethylene diamine tetraacetic acid, or we can also call EDTA. Can also call simply EDTA. Now, chelating effect. Chelating effect is enhance affinity of chelating ligand, enhance affinity of chelating ligand for a metal ion compared to the affinity of non-chelating or monodentate ligand for the same metal. Greater the chelating effect, greater will be the stability of resulting complex. For example, in copper ethylene diamine complex have higher stability constant than here copper methylene amine. Here, these are the chelating agent. Ethylene diamine are a chelating agent or bidentate ligand. One ligand form two bond. In that complex, here the monodentate ligand, methylene amine. Methylene amine are the monodentate ligand. One amine forms single bond with copper. For that, here ethylene diamine copper complex are more stable or having a high stability constant as compared to the methylene amine copper complex. Some ideal properties of chelating agent are here. The chelating agents are highly soluble in water. They have low affinity for calcium, form non-toxic complex with toxic metal. They are biologically inert or faithful, more affinity for metal than the endogenous. Now, the next applications of chelating agent. Chelating agent play an important or vital role in many fields discussed here. For example, first field is agriculture. In agriculture, these are play an important role. For example, metal chelate compound are common components of fertilizer to provide micronutrients. Micronutrients, for example, magnesium, ferrous, zinc, copper, are required for the growth of plant are chelating typical convert these metal ion into insoluble solids that are of non-nutritional value to the plant. EDT is a common typical chelating agent that keeps this metal ion in soluble form. Some of the chelating agent can apply directly to the solid for root uptakes, others via foliar spray. Some are also well situated for use of soil culture as there is no formation of precipitates with the active fur range. Most of common chelating agents used in agriculture are EDTA, DTPA. In simple language, the chelating agents play a vital or important role in agriculture in the fertilizer and in to provide a micronutrient to the plant in a soluble form. These are two common chelating agents are used in agriculture. These are DTPA and EDDHA, or also another is EDTA. We see in last points EDTA, ethylene diamine tetraacetic acid. These are the common chelates that are used in agriculture field. Now the next, in extraction of metal, these are the very important application of chelating agent for extracting a chemical weathering or extracting or chemical weathering is attributed to chelating agent. For example, peptide sugar that extract metal ion from minerals and rock. Chelation solvent extraction are example of pre-treatment technique for the metal ion for aqueous sample. For example, seawater. If we want to extract a metal from seawater or minerals, rocks, then we use a chelating agent for that purpose to extract a metal ion in a pure form. In oil production, another application is in oils production. In oil field, chelating agents are used in stimulation treatment and for clearing surface facilities. Surface facility typical oil field chelating agent includes EDTA, HEDTA, hydroxyethylene diamine triacetic acid, NTA, nitrotriacetic acid, and citric acid are commonly used in oil industry. In industrial field, used as a catalysis. Some of the chelating agents are used as a catalyst in synthesis. Homogeneous catalysts are often chelated complexes. For example, BNF, bidentate phosphine. In Noiri, asymmetric hydrogenation and use in manufacture of synthetic menthol. Next, Noiri asymmetric hydrogenation. It is a chemical reaction in enantioselective hydrogenation of ketone, aldehyde, and imine. These are the homogeneous catalysis example. Noiri asymmetric hydrogenation. Hydrogenation, we know all addition of hydrogen across the carbon-carbon or carbon-oxygen double bond, but these are asymmetric, means stereoselective hydrogenation will be carried by using a chelating agent. Here these are the diketone acetate in the presence of ruthenium chloride of BNF as a chelating agent to give a stereoselective or asymmetric hydrogenation. These are the very important application. Preparation of synthetic menthol. These are the menthol synthesis. Here ethylene amine. Here BNAP also used for stereoselective dehydrogenation to give. These are stereoselective product. Now next, chelating agent used for heavy metal removal from electroplating influent. Chelating agent used to soften water in soap and detergent, that is citric acid. Chelation has little effect on the water's mineral content other than to make it soluble. For example, these are the citric acid are used to soften the drinking water or the industrial water that contains some soap or detergent. It is easily remove these impurities by coordination. Now, dental application. Dentin adhesive system were based on and manner chelating ligand with calcium on the surface of the tooth and generated very weak water resistance. Then another applications is chemical bonding. Pharmaceutical application, chelate complex of gadolinium are often used as contrast agent in MRI scan for body MRI scan. Then penicillin amine, which form chelate complex with copper, is used treatment of Wilson's disease Antibiotic drug of the tetracycline and quinolone families are chelates of iron, calcium, and magnesium ion.